If you have ever tried to build an AI agent, you know that feeling, right? That frustration when your prompts feel like they're built on a house of cards. Well, today we're diving into a whole new way to think about this, a new architecture to make our agents robust. I mean, you build something that feels so powerful, but then one tiny little unexpected change and the whole thing just shatters. It's a huge pain point for literally anyone building in the space. And this brittleness, it can lead to what the source material calls rogue genies. These are agents that follow your instructions to the letter, but with totally disastrous, completely misaligned results. Not what you wanted at all. So how in the world do we fix this? Well, we're pulling from the paper Genetic Prompt Engineering plus Context Engineering, a genome-style architecture for safe, self-evolving AI agents. And the big idea here is, what if we stopped writing these fragile one-off instructions and instead we started giving our agents a kind of digital DNA, a stable genetic core to guide everything they do? Now, this idea of baking safety rules right in, it's not exactly new. It's actually part of a long conversation that you could say started way back in the 40s with Asimov's 3 laws in science fiction. And more recently, we've seen ideas like a truth GPT. But this paper, it proposes the next big step, operational prime directives. And that brings us to the first pillar of this whole solution, prime directives, or PDs. Just think of them as the agent's core safety DNA. They're a set of rules that are unchangeable, heritable, and laser-focused on safety, truth, and compliance. And here is the absolute key to making this work. They are immutable. Every new child agent inherits these rules verbatim, exactly as they are. This is what prevents safety drift, making sure those core rules don't get watered down or, just misinterpreted over generations of agents. Okay, but safety DNA alone isn't quite enough, right? Agents also need situational awareness. And that's where the second pillar comes in, the context stack. It's this really disciplined structure for feeding the agent information in a very specific order, starting with its core role, its memory, then any relevant facts, what tools it can use. All of that happens before it even thinks about generating a response. So with all that in place, how do new agents get created safely? That's the third pillar, the spawn sequence. It's a super strict 4-step process. First, the agent clones the prime directives. Only after that can its task-specific genes be mutated. Then everything gets versioned, quality checked, and its lineage gets logged. The main principle? You always inherit safety. You don't reinvent it from scratch. And maybe the best part of all this is that it isn't just some far-off theory. This whole framework is designed so you can adopt it today. You can start with what's called a minimal viable genome. There are copy-paste templates and public notebooks so you can actually try this out for yourself. Look, this genetic approach, it really could be a major step toward building AI agents that are not just more powerful, but also predictably safe. To see exactly how it all works, you have to join us for the live build. Start with episode 1.